All right, and finally, elimination. So elimination sometimes is called the addition method, um, but yeah, elimination. And so elimination works well when things are stacked. So that's kind of my word. But when you have you see how your C's are stacked, your D's are stacked, your numbers are stacked, and especially your equal signs are stacked. So those are the kind of the best conditions for using elimination. Okay. Now this one's nice. This one wouldn't be too bad for substitution because we can solve for u. And so, but it's a little bit easier. Well, I don't know. You can definitely be the judge of if it's easier or harder. But this is nice for elimination because we have the nature of this situation. This system is that everything is aligned, right? Everything is stacked. All right. So with elimination, what we want to do is we want to make sure that the coefficients of one of our variables are opposites. So here we have like 2 and 3, right? So those are not opposites. But here we have -1 and +1. Those are opposites, right? So there's invisible 1 here, invisible 1 here. So when you have that situation, all you have to do is combine these equations. That's why it's called the addition method sometimes, because we're just adding these equations together. So, and we can do that, right? Because remember, this side is equal to this side. So by the addition by the addition property of equality, we can add equal values to either side of the equation, right? Or to both sides of the equation, and it still keeps the same value. So we're just adding two equal things to both sides, and so that keeps the integrity of the equation. So anyway, so if we add 2t and 3t, we get 5t, right? If we add negative u and positive u, they cancel out. They get eliminated, right? Which is where elimination comes from. And then 17 plus 8 is 25. So now we went from having two equations and two variables to just one equation and one variable, right? Just like with substitution, but this one's a little nicer because all we have is just one step. At least this step is nicer. You'll see the next step is a little bit longer, I think. All right, so we get t equals 5. So that's one of our one of our variable values solved for, right? Now we have to find the other. So what we need to do is we need to plug this 5 in, and we can plug it in here or we can plug it in here. It's your choice. So pick the one that you think is easiest. I would probably pick the second one because the other variable is positive. So you know, kind of go by convenience, but they both work. You'll get the right answer either way. So what I'm going to do is I'm going to rewrite this second equation here, 3t plus u, but I'm just going to leave space to put the 5 in for t. So I'm going to put that 5 in there. Okay. And so we'll get 3 times 5, which is 15, plus u equals 8. Then we'll subtract 15 from both sides, and we get u equals -7. Okay. So we get t equals 5, u equals -7. So those are our answers. Okay, that's our solution. All right, so number 9. So here we can see that we don't have variables that are opposites, right? We have two that are the same, 3 and 3, and then we have these two that are opposite signs, but they're not the same number, right? They're not opposite values. And so we can do one of two things. So you can multiply any equation by whatever you want on both sides, right? So I could multiply one of these equations by -1, and that would get these 3's to be opposites so that I could cancel out the c's, or I could multiply this equation by +2, and that would make this -4, and then we could cancel out our d's. So you have choices. Either way works. I think it's probably a little easier to multiply by -1, so I'll do that. So I'll multiply this top equation by -1, so it'll turn into -3c minus 2d, or excuse me, plus 2d, sorry, because I have to multiply everything by -1, right? And then -2. So basically multiplying by -1 just changed the sign of everything in the equation. So this other equation, I'm just going to bring it over. +3c plus 4d equals 50. So I didn't change that at all. And so now what's going to happen is these 3c's cancel out. And so we end up with 6d equals 48, negative 2 plus 50, right? Then we can divide both sides by 6, and we get d equals 8. All right, so now I can plug that in for one of the other equations. You can plug it into any one you want. I'll just do this one right here because, once again, everything's positive. So I'm going to do 3c plus 4. I'll leave space for the d equals 50. So then I'm going to take this value 8 and plug it in there. So we get 3c plus 32 equals 50. Subtract 32 from both sides. And so we get 3c equals 18. Divide by 3. And we get c equals 6. So c equals 6, d equals 8. Those are two values. If you put them in as a coordinate pair, just do alphabetical order, 6, 8 with parentheses. But you don't have to do that. And so let me see. Let me just mention that elimination sometimes is easier on the front end than substitution, but then it's a little more work on the back end because we don't have a variable by itself. So we have to do a little more work to solve for our second variable. Okay.